So we have quick sort, and quick sort, here is the example function. So we are saying quick sort. Here is the code for quick sort. Quick sort takes like three parameters: first the array, then the left and the right index, and the base case will be left is greater than equal to right, then it will do nothing, it will directly return. But if left is less than right, then it will first find an integer p using the function partition, which takes like the array, the leftmost part of the leftmost element of the array, and then it takes these two indexes, left plus 1 and right. Then what p does is like, let me show you what p does. So here is what partition function does. It will firstly the leftmost element is 4, so it will take the pivot as 4. Then it will make the index of left plus 1 as 0, I as this index, and suppose I'm just making it 0, it might not be 0, it might be some other number. Then this index will be 6. Firstly 4 will be compared with 3, and if 3 is less than 4, then index I will be increased. Then 9 will be compared, it is greater, so 9 will be moved to the back and 8 will be moved to the ith position. And sorry, this was j, so j then will be decreased. Now it will be 4 will be compared with 8, again 8 is greater than 4, so 7 will be moved here, 4 and 8 will be moved here, and j is decreased. Again 4 will be compared with 7, again 7 is greater than 4, so 3 will be moved here and 7 will move here at the jth index. Then j index will be reduced. Again like 3 is less than 4, so now I will increase. Again 2 is less than 4, so again I will increase. And again 1 is less than 4, so I will increase. And then I will return the value of j. So let me show you what initial array was and what the final array will be. So this was our initial array, and the partition function basically converted it to this array. So this is our final array, and the index j is pointing to 1 and j is returned, and the I is this index pointing to 7 in this case. So j was returned and j will be made as p, and then what we do is we swap the left element and the pth element. So after swapping, this will be our array. 1 will come at this position and 4 will go to the position of p, and then we have 7, 8 and 9. So now quicksort will be done on these two arrays, the left part of 4 and the right part of 4. You can see in this case that the left part of 4 is like all the array left to the 4 is smaller than 4, and all the array to the right of the 4 is greater than 4. So this continues with quicksort, and in this manner quicksort is able to sort the array perfectly. So the worst case time complexity for the quick sort is in the case when the array is already sorted. In that case, t of n will be t of n minus 1 plus O of n, because if the array is sorted, the leftmost index will be already at its actual position, and then we will do quick sort in the like right part of it and the left part of it. Left part of it is empty, so the quick sort will only be done on the right part of it. So it is t of n minus 1, and O of n is because of the partition function which calculated the position of the pivot, the actual position of the pivot. The best case would be if the pivot position is found to be at the center of the list, which is 2 of t of n by 2 plus of n, and then t of n will solve out to O of n log n. The average case could be found in this manner. The average case is that suppose for the array of size n, the pivot can be found at the first position, second, or at the nth position. If it is found at the first position, then we will use t of 0 and t of n minus 1. If it is found at the second position, then we will use t of 2 and t of n minus 2, and similarly we have this, and we have to average it out because we are having like the n cases here, so we will average it out, and then the partition function takes of n, and this will so because of symmetry, this will be t of n is equal to 2 by k summation k from 0 to n minus 1 tk, and then O of n, and it will solve out to be t of n is O of n log n. So the average case complexity of quicksort is n log n.